Scene script. Have you ever wondered how crucial it is to understand anti-adrenergic drugs and how they can change the course of your health? Picture this. Your body is a magnificent orchestra, with hormones and neurotransmitters as the virtuoso musicians playing a symphony of functions. Among the maestros, adrenaline, also known as epinephrine, takes center stage. It's the hormone that prepares us for fight or flight, coursing through our veins when danger lurks. But what happens when the adrenaline performance goes out of tune, causing high blood pressure or irregular heart rhythms? Enter the unsung heroes, anti-adrenergic drugs. These drugs are like the conductors of the orchestra, ensuring everything runs smoothly. They control the effects of adrenaline by blocking its receptors, hence the term adrenergic blocking drugs or Adrenoceptor antagonists. But they don't just block any receptor. They specifically target adrenoceptors, the sites where adrenaline and noradrenaline bind and exert their effects. Now you might wonder, why is it so important for us, or for pharmacologists, to understand these drugs? Well, the answer lies in their widespread use. Anti-adrenergic drugs play a pivotal role in treating various cardiovascular disorders, like hypertension and angina, and even some forms of anxiety. They work by calming the symphony, slowing the heart rate, and reducing blood pressure. But it's not just about calming the storm. The beauty of these drugs lies in their variety. Some are non-selective, blocking both types of adrenoceptors, alpha and beta. Others are selective, choosing to block one type over the other. Then there are reversible and irreversible antagonists, each with their unique benefits and drawbacks. So, you see, understanding anti-adrenergic drugs is not just for the white-coated pharmacologists in labs, it's for all of us. It's about understanding the symphony that plays within us, the maestros and the conductors that keep our bodies in harmony. Understanding anti-adrenergic drugs might seem complex, but it's truly intriguing. Let's dive into it. The pharmacology of adrenoceptor blocking drugs is like a puzzle, fascinating and complex, yet solvable. To understand this puzzle, let's break down the basics. Adrenoceptor blocking drugs, often referred to as blockers, are quite the superheroes. They swoop in to block the action of adrenaline and noradrenaline, hormones that rev up our body's fight or flight response. Now these blockers have a knack for disrupting the party at the adrenoceptors, the sites where adrenaline and noradrenaline love to hang out. These receptors are scattered across various organs, and depending on their type and location, they control different body functions. At the heart of the mechanism of action of these blockers is their ability to bind to the adrenoceptors. Think of it as a key fitting into a lock. Once the blocker, our key, fits into the adrenoceptor, our lock, it prevents adrenaline and noradrenaline from doing so. This inhibition dampens the body's response to these hormones, slowing heart rate, decreasing blood pressure, and soothing anxious nerves. Interestingly, not all blockers are created equal. Some are like polite guests who leave the party after a while. We call these reversible antagonists. They bind to the receptors temporarily, leaving after some time, allowing the hormones to bind again. On the other hand, we have the irreversible antagonists. These blockers, once they bind to the receptors, are there to stay. They permanently block the action of the hormones. Then we have the selective and non-selective antagonists. Selective antagonists, as the name suggests, are picky. They choose specific types of adrenoceptors to bind to. Non-selective antagonists, however, are not so choosy. They bind to various types of adrenoceptors, blocking the action of the hormones across multiple sites. Just like solving a puzzle, understanding the pharmacology of these drugs can be challenging, yet rewarding. As we delve deeper, we uncover the intricate mechanisms that help us control the body's responses, and ultimately, improve health. So let's keep decoding this fascinating world of adrenoceptor blocking drugs. What if I told you, not all anti-adrenergic drugs work the same way? Let's dive into the intricacies of these drugs, specifically the reversible and irreversible antagonists. Now these terms might sound intimidating, but let's break them down. Reversible antagonists, as the name suggests, can be reversed. Imagine a dance floor, where partners can swap and change at will. That's how reversible antagonists work. They bind to the adrenoceptors, but this bond isn't permanent. They can be displaced by other molecules, allowing them to be removed from their binding sites. This gives them a flexibility of action, as their effects can be nullified if required. Now let's move on to irreversible antagonists. Picture a dance where once a partner is chosen, they're locked in for the entire night. Irreversible antagonists form a permanent covalent bond with the adrenoceptors, and they can't be removed from their binding sites. This means their effects are long-lasting and can't be reversed, even when the concentration of the drug decreases. Understanding these differences is crucial in the world of pharmacology. It helps us determine the right drug for the right situation. For instance, reversible antagonists are often preferred in situations where we might want to reverse the effects of the drug, like during an emergency. On the other hand, irreversible antagonists are useful when we want a sustained, long-term effect. So you see, even though they fall under the same umbrella of anti-adrenergic drugs, reversible and irreversible antagonists work in profoundly different ways. It's almost as if they're two different dancers, each with their unique rhythm and style, dancing to the same tune but interpreting it in their distinct ways. Isn't it fascinating how even within the same category these drugs can have such different characteristics? Now let's delve into the contrasting world of selective and non-selective antagonists. In the grand scheme of pharmacology, antagonists are like the chess players of the body, making calculated moves to block or inhibit certain biological functions. But not all antagonists play the game the same way. Enter the contrasting worlds of selective and non-selective antagonists. Selective antagonists are like chess players who have a particular strategy, a specific piece they are targeting. They bind only to a specific type of receptors. They're the snipers, the sharpshooters. They have their sights set on a single target and they don't deviate. They're specific, precise, and highly targeted in their approach. For instance, in the realm of anti-adrenergic drugs, there are selective antagonists that only target alpha or beta receptors. Imagine them as the specialists with a deep knowledge of their chosen field, blocking only the specific adrenoceptors they're designed to interact with. This selectivity allows for targeted treatment, minimizing potential side effects by avoiding unnecessary interaction with other receptors. On the other hand, we have the non-selective antagonists. These are the players who are ready to make a move on any piece that comes their way. They're the generalists. They can bind to multiple types of receptors, not just one. Like a jack of all trades, they're versatile, adaptable, and ready to interact with a variety of receptors. In the context of anti-adrenergic drugs, non-selective antagonists can block both alpha and beta receptors, providing a broader scope of action. However, this lack of selectivity can also mean a higher potential for side effects, as they can interact with receptors that aren't involved in the condition being treated. It's a bit like using a shotgun approach. It might hit the target, but it can also cause collateral damage. And so the battle continues, as researchers and pharmacologists strive to strike the perfect balance between selectivity and non-selectivity, specificity and versatility. Each has its place, its strengths, its weaknesses, and its unique role to play in the fascinating game of pharmacology. The world of anti-adrenergic drugs is so diverse and riveting, isn't it? While we've learned so much, there's always more to explore in the world of anti-adrenergic drugs. As we've journeyed through this fascinating realm together, we've unraveled the mystery of these drugs, decoded their pharmacology, and taken a closer look at both reversible and irreversible antagonists. We've even stepped foot onto the battlefield of selective and non-selective antagonists. Let's take a moment to recap. Anti-adrenergic drugs are a class of medications that block the effects of adrenaline and noradrenaline, playing a vital role in managing conditions such as hypertension, heart disease, and anxiety. Understanding the pharmacology of these drugs is crucial. It's not just about knowing their names, but about comprehending how they interact with our bodies, how they can help heal us, and sometimes challenge us. We delved into the world of adrenoceptor blocking drugs, exploring how they work by inhibiting the action of adrenaline and noradrenaline. We discovered that these blockers can be reversible or irreversible. Reversible antagonists bind temporarily to adrenoceptors, while irreversible ones form a permanent bond, blocking the receptor indefinitely. Our exploration didn't stop there. We navigated the complex terrain of selective and non-selective antagonists. Selective antagonists target specific adrenoceptors, while non-selective ones have a broader reach, blocking multiple types of adrenoceptors. Each has its own set of benefits and challenges, and understanding their differences is key to their effective use. The world of anti-adrenergic drugs is vast and ever-evolving. Whether you're a seasoned pharmacologist or a curious learner, having a solid grasp of these drugs, their mechanisms, and their implications is invaluable. It's a testament to the incredible complexity of our bodies and the science that seeks to understand and aid them. Remember, knowledge is power. So subscribe for more because you won't find me later.